Welcome to the Wafi-Golpu Tailings Management video. This video will present information on the Wafi-Golpu Joint Venture's evaluation of tailings management options for the Wafi-Golpu project and details about its selected deep-sea tailings placement method. The most important priorities in selecting an option to manage tailings from Wafi-Golpu is the safety of our communities and management of the environment. Deep-sea tailings placement uses a combination of the natural ocean layering characteristics and the local geological setting to deposit tailings safely in deep water. The tailings are deposited at depths well below the shallow marine coastal environment where fishing takes place. What are tailings? Tailings are what is left after the copper and gold are removed from crushed ore rock. When the ore is brought up out of the mine to the process plant, it is mixed with water and ground down to the consistency of fine sand. The valuable minerals are separated from the rest of the ground rock and made into a concentrate. Separation of the valuable minerals is achieved by frothing the ore using compounds similar to detergents. No cyanide is used in this process. The leftover fine sand-like material is referred to as tailings. Tailings must then be stored in a safe and environmentally sustainable manner. How can tailings be managed? One option is land-based storage in a purpose-built tailings dam, or via dry stacking of the tailings. Another option where land-based storage is not technically viable or environmentally sustainable or safe is deep-sea tailings placement, or DSTP. There are many factors to consider when selecting a tailings management option. These include the site geology, topography and soil and rock foundation conditions, earthquake or seismic risk, and the climatic conditions of any proposed site. The environmental, social and cultural heritage setting and any constraints must also be considered. Mine closure risks and ongoing management also inform the decision-making. The design must also cater for the characteristics of the tailings. Some tailings disposed in a land-based tailings storage facility can contain natural minerals which, when exposed to oxygen, can cause acid rock drainage leading to acid runoff and the release of heavy metals. Experts engaged for the project forecast that the ore processed would be potentially acid-forming. However, if tailings is stored away from oxygen, there is no opportunity for them to become oxidized and release heavy metals. One way to exclude oxygen and limit acid formation is to store the tailings underwater. Seawater in the deep ocean typically has an alkaline pH and low oxygen levels, which limits oxidation. Why doesn't Wafi-Golpu build a tailings dam? The proposed Wafi-Golpu project will need to store approximately 360 million tonnes of tailings over the life of the mine. The size of the dam required would likely cover an area over 5 square kilometres, potentially leaving some communities completely without land for future farming or living. Between 1993 and 2017, 45 potential dam sites were examined and assessed as shown in this map. 4 of these sites were studied in detail over the course of the project's feasibility studies. A combination of factors meant that constructing a dam in any of these areas was not feasible or would result in an unacceptable level of risk from an environmental, cultural heritage, engineering or safety perspective. Papua New Guinea is one of the most seismically active regions in the world. Many of the possible dam sites examined had active geological faults which would intersect the siting of the dam walls. In the event of an earthquake, these faults could cause the dam to fail. The high rainfall experienced in the area also makes water runoff from a large dam more challenging. The combination of these factors makes the risk of dam failure for those options considered for the Wafi-Golpu project unacceptably high. In addition, many sites presented unacceptable environmental and social impacts, such as the destruction or disturbance of significant cultural heritage areas. On the other hand, DSTP has a much lower impact on communities around the mine who depend on their land, biodiversity, and cultural heritage values. The safety of our communities and management of the environment are our most important priorities. The hydrodynamics of the Huon Gulf. The Huon Gulf and Markham Canyon are ideally suited to DSTP because of the physical and oceanographic features of the Gulf. In the vicinity of the city of Lae, the Markham River and the Busu River enter the Huon Gulf. Further east along the coast toward Finschhafen, several more rivers enter the Gulf from the Saarauwugged Range to the north. Every year, these rivers discharge large quantities of rocks, gravel, sand, silt and clay into the ocean. As a result of these sediments, there are no coral reefs close to these river mouths. Recent studies estimate that these same rivers carry over 80 million tonnes of sediments into the ocean every year. In some oceans around the world, ocean currents or wind-driven forces can mix different layers of water within the water column. However, the ocean in the Huon Gulf has several layers which do not mix with one another. The surface layer of the ocean is warm and is affected by winds and waves. At the bottom of this layer, the ocean becomes much colder and more saline, and as a result more dense or heavy. The warm layer floats on top of the cold water below. Measurements taken by the scientific studies reported in the Wafi-Golpu Environmental Impact Statement and since have shown that the upper mixed layer changes in thickness throughout the year responding to wind and waves. The maximum depth of the mixed layer extends to 96 metres below the surface, occurring in August-September during the windiest period. Specialist surveys taken over a 4-year period have demonstrated that upwelling does not occur in the Huon Gulf under any seasonal conditions. The uppermost layer of the ocean receives enough sunlight for the growth of seaweed and phytoplankton. This layer is called the euphotic zone, where light penetrates to about 60 metres below the surface. Below this level, the ocean is in constant darkness. Most fish life and all phytoplankton which provide food for fish live in the euphotic zone. Most of the fishing carried out by coastal fishermen occurs within this layer of the ocean. The bathymetry of the Huon Gulf. Below sea level, the seafloor plunges steeply into a deep ocean canyon called the Markham Canyon. You can see in the image that the bottom of the Markham Canyon is flat like the floor of a river valley. This video shows the dynamic environment 150 metres off the canyon floor, with strong currents sweeping sediments further down canyon. This canyon floor is the area receiving the naturally occurring sediment that is currently discharging from the mouth of the rivers. The floor of the canyon does not have clear water suitable for most fish life and lacks biodiversity because it is filled with river sediment that is constantly being transported along the canyon into deeper waters. On the southern side of the Huon Gulf from Labu to Salamoa, there is a wide flat terrace area, which then leads to the steep-sided Markham Canyon about 3 kilometres offshore. This imagery shows less turbid waters and the soft sediment seafloor outside of the canyon that also shows some evidence of marine life with a few trails and burrows observed. On the north side of the Gulf in the area from Lae to Bukawa, the slope into deep water is steep from very close to the shore. We now move to the vicinity of the proposed outfall location. In this imagery, you can again see the soft sediment seafloor with little evidence of marine life. At this location, rounded river rocks are also observed as they are transported offshore and into the canyon. In the area offshore from the Busu River and Wagang, the ocean slopes steeply down to a depth of 700 metres below the surface. The Markham Canyon floor eventually slopes down and extends into very deep water close to 9 kilometres deep in the New Britain Trench, about 100 kilometres to the southeast. The dynamics of the Huon Gulf. When the rivers which enter the Huon Gulf discharge into the ocean, the coarse gravel and sands flow down the submarine slope into the Markham Canyon. The fine silt and clay material settles and builds up on the slopes of the steep submarine valley walls. Eventually, this built-up material becomes unstable and slides down the steep valley slope and into the Markham Canyon via a naturally occurring submarine landslide or avalanche. This happens approximately once every 3 weeks. This avalanche of sand and mud rushes down the Markham Canyon for many kilometres and eventually settles in the lower stretches of the canyon and in the very deep New Britain Trench. These natural events are very powerful and destructive to the seafloor environment. During the project's scientific studies, one of our observation buoys, which was weighted to the bottom of the canyon with a 900 kilogram weight, was picked up and moved 16 kilometres downslope by the force of one of these submarine landslide events. These events mean that the existing seabed environment is highly disturbed, and marine life within the Markham Canyon is very limited. The DSTP system. The Wafi-Golpu project plans to transport its tailings from the mine site by buried pipeline to an outfall area near Wagung village to the east of the city of Lae. This tailings pipeline is similar to the many other buried water or sewage pipelines that currently run through the city of Lae. The tailings arrive at the shore-based mixing tank from the pipeline which comes from the mine. In the mixing tank, the tailings are diluted with cold seawater, which is brought up into the mixing tank from over 60 metres below the surface of the sea. This seawater is mixed with the tailings, and any small bubbles which may have been trapped in the tailings can escape. This means there are no bubbles in the tailings to carry them upward within the ocean after they leave the outfall pipe. The diluted tailings are then sent through pipes laid on the seafloor to be discharged about 700 metres offshore from Wagung at a depth of approximately 200 metres below the surface. This is a depth equivalent to 6.5 times the height of IPI House, the tallest building in Lae. This depth is over 100 metres below the maximum depth ever reached by the warm layer of the ocean in the vicinity of the outfall. This is also well below the level in the ocean at which local fishermen catch their fish. The water at 200 metres deep is cooler, and the dense tailings slurry is prevented by the tailings density from rising up into the less dense and warmer mixed layer that is over 100 metres above. After coming out of the pipe, the tailings then flow like a river down the seafloor slope to reach the bottom of the Markham Canyon, at a depth of about 700 metres below the surface, following the natural seabed of the area. Modelling demonstrates that a small portion of fine tailings is expected to separate off the main flow as dilute plumes at depths below 300 metres. These dilute plumes also eventually settle to the sea floor, along with the other sediments discharging from the local rivers. As the tailings flow down the slope and into the canyon, they will mingle with and become diluted by the naturally occurring river sediments flowing into the Huon Gulf. Once mixed with the river sediments, the tailings represent less than 20% of the total naturally occurring sediment flow in the area. Once the tailings arrive on the bottom of the canyon, they will be transported into very deep water with natural sediments, including through regular natural submarine landslide events that take place. This process will mix the tailings with river sediments and ultimately result in them being buried by the naturally occurring sedimentation. Very little sea life currently exists in the environments of the Markham Canyon and the New Britain Trench, where tailings will be deposited. This is because of the highly turbid environment from natural sediment transport and from regular submarine landslide avalanches. This creates a highly dynamic and hostile environment in which living things in the sea floor are either disturbed or rapidly buried by natural sediment transport and landslides. Will the fish be safe to eat? Fish in the Huon Gulf will remain safe to eat. DSTP is not predicted to affect the community's fish catch. Local fishermen mostly catch fish at depths less than 100 metres. The tailings will be discharged at a depth of approximately 200 metres, and expert studies conducted for the Wafi-Golpu Environmental Impact Statement concluded that the density of the tailings, the lack of upwelling, and the natural hydrodynamics of the area will prevent the tailings rising above the discharge depth of some 200 metres. As a result, it is highly unlikely that these fish will come into contact with tailings discharged into the deep ocean. The Wafi-Golpu project conducted environmental studies focused on fish catches in the area proposed for DSTP, as well as control areas further away from the proposed DSTP discharge area. These studies provided confidence that the proposed DSTP operations are not predicted to affect the community's fish catch, and the fish will remain safe to eat. The project will continue to work with local fishermen and local fish markets to monitor their catches and undertake scientific studies on the fish to check there is no accumulation of metals in the flesh and organs of the fish which could be derived from the tailings. The Wafi-Golpu project will look to purchase locally caught fish to serve in our camp dining facilities, as a measure of our confidence that the fish will remain safe to eat. There are predicted to be no impacts from DSTP to commercial tuna fisheries because these fisheries and tuna breeding grounds are not located within the Western Huon Gulf near the proposed DSTP system outfall location. DSTP monitoring. Outside the approved mixing zone, the tailings discharge is diluted to levels that meet the PNG water quality criteria and the Australian and New Zealand water quality guidelines for marine aquatic ecosystem protection. The Wafi-Golpu joint venture will establish a participatory monitoring partnership with local communities, government regulators and other key stakeholders throughout the life of the project to inform people about baseline conditions as they exist today and monitor operations into the future. We would like all interested people to be informed with scientific facts about the performance of the DSTP system. Mine closure. After closure of the mine, the tailings flow will cease, and natural river sediment transport and submarine landslide events in the Markham Canyon will continue to occur. This naturally occurring sedimentation and landslide activity is expected to further transport the mixed sediment and tailings deposits into very deep water, eventually burying the deposits and allowing the deep sea environment to return to its pre-mining condition. The Wafi-Golpu joint venture is confident that DSTP is the safest and most environmentally and socially responsible tailings management solution for the Wafi-Golpu project for the duration of its operations and beyond mine closure. For more information, please visit our website to review the project environmental impact statement at www.wafigolpujv.com.